evening, everyone, and welcome to this meetup. And I hope everyone is doing good in this pandemic situation. And yes, I know it's been quite a lot of months like which we have passed, and I really hope that we get the cure. Uh, but let's hope for the best and sit tight. And before I start, I would like to thank Sean for providing us this opportunity and platform. I know, Sean, I've been like bugging you a lot, but thanks again, buddy, for this. And let me start with introducing myself. So, hi, I am Piyush Rana. I am a lead Scala consultant at Knoldus Incorporation, heading the technology division here at Canada. I'm a Lightman certified reactive architect, and is a kind of a functional programming enthusiast with having experience in like product development, consulting, managing project management, working across several domains. I love to work in like Scala, Java, Python, and some well-known big data framework. Uh, and also, like at the end, like I'm an author for a book called Programming in Scala. That is a practical step-by-step approach for your functional programming. It's like one of our Knoldus programming series book, which is available at Amazon and other leading platforms. So, yeah, I think that's all from about me. And I would also like to like brief something about my organization. So, so we Knoldus is basically, I'll say we are a group of smart engineers with a product mindset who works along with your business to deliver a competitive edge. We have a great people like working together now, and we have grown up to the size of 200 plus. And I'll say that we have took some industry's best practices and approaches, and then we have amalgamated them with our Knoldus core values. And finally, like I'll say, we have formed a flexible, fun, and a kind of a creative organization. Yes, you can like hop onto our website, www.knoldus.com, to see some cool and exciting stuff that we work on, and you can learn about us more. And yeah, so here are like a gist of them, which I was talking about. And basically, these are our various practice areas or the tech domains and tech stacks and the domains that we work on. So we do follow like best practices in the areas of product engineering, reactive UI UX, test automation, and reactive DevOps. So that's about me and the organization. So let's come today for today's topic. So let's talk about the agenda, like what we will be gonna covering today. So we have like we'll start with like discussing about the Flink cluster. What exactly is this Flink cluster, and basically what does it comprises of? Then we'll do a little bit deep dive into the terms of Flink, like the task slots, the resources, and so on. And then we'll talk about like different types of Flink application that we can create and we can deploy, and what are their execution type. And finally, then we'll see like, so we are using Google Operator as a deployment operator on the Kubernetes. So we'll see like how we have used Google Operator to deploy our Flink jobs on Kubernetes with a little demo at the end. Okay, so coming to the anatomy of our Flink cluster. So basically, like the Flink runtime, if you see, so it consists of two main like big processes. One is your job manager, and another is your task managers. Maybe of course the task managers can be one or more. So and both of these, like if you see like the job manager and the task managers, they can be like started in various ways. Like you can directly deploy it on your machines as a standalone cluster. For example, like while you're doing the development, you can run them as your mini cluster inside your IntelliJ or any of the build tool which you are using, or you can deploy them under containers or any managed framework, resource framework. For example, like you have Yarn, you have Mesos, you have Kubernetes. So these can be deployed anywhere. And the like the structure of this cluster remains the same. Like we follow basically they follow the same fundamental units, that the task manager has to connect with job manager, and they announce them, hey, I'm available while sending the heartbeats. And the task manager asks for the work, the job manager assigns work to the task manager, and so on. So this is how like your cluster, these are like the two basic components or I'll say the major components which are comprises of your Flink cluster. Then the third component comes is your Flink application. Basically, that's your main code which you're gonna run on your cluster. So before discussing that, let's discuss a little bit more about your job manager and your task manager. Of course, like being as a master, job manager has a number of responsibilities, right? And it's a kind of similar thing which you might have seen in other frameworks. Like, for example, if I talk about like Spark framework, there also you have Spark master, you have Spark workers. Similarly, something similar is there. You have job manager and your task manager. And but here, like the job manager, there are three basic components that it handles. First is like your resource manager, your dispatcher, and your job master. So there are like, I'll say, there are various responsibilities for the job manager, right? So it's like coordinating your distributed execution of your Flink applications. Then it has to coordinate what happens with your what happens when the task is finished. What happens if something fails? It has to coordinate the checkpointings and so on. So all of these responsibilities are basically divided in three parts. So there's resource manager, which basically takes care of allocation and deallocation, and it manages the task slots, which is another like key unit in Flink cluster. And when you wanna deploy your Flink cluster, or basically when you deploy your jobs on your Flink cluster, so you have to take care of these things. Okay. Then comes your dispatcher. So dispatcher basically it provides you the REST interface to submit your Flink application for your execution and start of your job manager. It also provides you a Flink web UI. So it gives you a beautiful UI where you can see your information about the job that you have submitted. And then comes the job manager. So, and it's like your final, like the job master, basically, which is like responsible for managing your execution, right? Of course, like there can be multiple jobs that can run on your Flink cluster, but each should have their own single job manager. So that's the key constraint. And in production environment, you don't want to go with a single-handed job manager, right? You want to maintain your high availability with you. So for that, yes, you can have multiple job managers where one will act as a leader and other will act as a standby. On the other hand, if you see, when it comes to the task managers, so they are your basic unit of your working unit, and they are known as like workers also, which basically executes your data flow, exchange your data within the streams, and so on. And as like compared as similar to your job manager, you should have at least one task manager in your cluster. Of course, like that would be doing your work, and then there are task slots which are divided into that, which let's see, we'll see like in ahead slides. So I think this would give you a concrete idea what exactly Flink cluster consists of, how does it looks like, what are its main components, how do they basically work in pretty simple manner. And then there was one third component, I think, which we saw in the previous slide, that is your application, basically your application which you want to run it. But there was one like client was, there was another component down there that was your client, right? So yeah, let's do one thing. Like let's make it more maybe interactive. Otherwise, people would get bored. So I ask you, like guys, in this thing, like, do you know what exactly is this client and what exactly it is being used for? Maybe we can again use that chat box if like anyone wants to speak, you can speak up and I can reply. We can chat on the chat box also. Any idea like what exactly is this client for? Because it does play like a kind of a good role while you deploy your job. Okay, so let me unwrap the mystery by myself. So basically, this client is basically, it's not a part of your runtime or your program execution. So it is basically used to prepare and send your data flow to your job manager. So it's basically used to submit your jobs, your jar file or your application code, and it basically resides as a part of your Java or Scala program, basically that triggers the execution, or basically it resides in the command line processes. So if you have like downloaded the Flink library, so you will see like in your bin folder, you have Flink binary to submit your jobs. And there's a run command down there through which this client interacts and submits your job. So the major point here to keep in mind is that there are basically two modes for this client. One mode is your detached mode, and another mode is your attached mode. So in your detached mode, basically the clients get disconnected as soon as it submits the job. And if you are running your Flink program as in your attached mode, so the client stays connected and it receives the progress report from the job manager. So it depends upon you, like, and it depends upon the medium, like where are you gonna deploy your Flink cluster, whatever like operator or whatever third-party tool you're using to deploy it on whichever platform. You can like leverage these two modes to get more and more information and make your like life easy and work easy. So this screenshot, which you are able to see like on the bottom, so this is like a screenshot in which the job has been submitted to the cluster in a detached mode. And as you can see, like in the detached mode, the client gets just disconnected, and it will tell you like, hey guy, like I don't have any other information about the job. And if you need like what is happening to your job, either go to the UI or whatever like logging mechanism you have configured, take the help from that. Okay, makes sense. Okay, so let's move ahead and let's talk about the task slots and resources. So these are like the I can say components of your Flink cluster, which are another crucial components that you have to take care of when it comes to deploying your job on the Flink cluster, because like you have to decide like how many task slots you have to manage, how many task slots you have to assign to your task manager, and so on, like how many actual task managers you have to assign. So in general, like basically the number of task slots that are there in the task manager, it basically indicates your number of concurrent processes that are running. So that's why they plays a crucial role in determining the parallelism of your job. So as many task managers as you have, that many parallel tasks you can span on your task manager. But it comes with it comes with little tricky part. That is like each task slots basically represents a fixed subset of resources of that task manager. So what does that mean? It means like, for example, say you have 3 task slots in your task manager. So what the task manager will do, it will dedicate 1/3 of its managed memory, which is a part of, which is a part of your Flink physical memory. So it will manage that. It will like dedicate 1/3 among all of those 3. So among to each and every slot. So this way, like you will have a resource constraint with each and every slot, and then you have to determine like how many parallel tasks you want to run. This also have an advantage. It's not like that it's a kind of a disadvantage for it. The major advantage of it is that the slotting these resources basically in the subtasks. When you do that, so what will happen? The subtasks will not compete with other subtasks from that job or any other job for that managed memory. Each will have their own managed memory, and as like they'll have their own certain reserved managed memory with them. This only happens with the managed memory. Like this concept only remains with the managed memory for the task slots and dividing the resource. It has nothing to do with your CPU. So like it's another consideration to keep in mind. Like you don't have to worry about your CPU unit that you are allocating to your task manager, but yes, you have to be careful while you are allocating your total memory to your task manager, as well as how many slots that you want to go with that. Okay, so this whole basically comprises of your Flink cluster. Now comes like the part where you have created your application, and now you have to decide like, how do I want to deploy my application to my environment? Now, of course, now what is a Flink application? As you saw, like Flink application is basically your user program that can run on multiple Flink, jobs from its main method. The execution of these jobs can basically happen anywhere. Like you can run it on your local right, on your local environment, or you can run it on your remote set of clusters, where those clusters can be running on your like any remote environment, like on your Kubernetes cluster or anywhere. And basically, it's not like there are some set of methods that controls the job executions also. So you'll have like a set of methods provided by your execution environment, that what is your parallelism that you want to do, what's the checkpointing that you want to have, where do you want to save your checkpointing, and so on. But that is everything about Flink application. But when it comes to decide like where, in which execution type do you want to deploy a Flink application, so there are basically few types of execution environment that is provided by Flink to us. So again, an open question to everyone who is there in the call. Can anyone tell me like what are the execution types that we have with the Flink application? Like I saw like a few people said that they work.
Well,
Flink. Right?
Did you say that the attach and detach, right?
No, it's not it's not the attach and detach are the way to deploy your Flink job, but I'm referring to like how many types of cluster you can create for Flink. So those are your execution types for your Flink application. Okay, and I'll give you like maybe this slide, maybe this picture may help you to recognize them. So you know that like there are three types of cluster that you can span on Flink. One is your Flink session cluster. It's kind of a long-running cluster. One is your Flink job cluster, which is also known as a dedicated Flink cluster. And third one is your application cluster, which is kind of a mixture of both of these. But yeah, the difference between these three are mainly related to the life cycle, what your job would be having, and to the resources, like how the resource allocations are being guaranteed. So does these sounds familiar to you, guys? Flink, tree?
Yes. Now I remember that.
Okay.
Yeah, I get it.
Great. So I have, so I have tried to like comprise the difference between these three jobs in this tabular format. So because like that's these are the like main key points that you have to keep in mind before choosing like which cluster do you want to go with, and like we decided before, like how many task slots I want to go, how many task managers do I want to go with. So that all comprises of helps you to basically decide which cluster finally you are going with. So let's start with like Flink session cluster. So in Flink session cluster, basically you can see like it's a kind of a pre-existing long-running cluster that can accept like multiple job submissions. So what does that? It means like basically like you can span up your cluster and you have like dedicated allotted some nodes and resources to this cluster, and now one by one you're submitting your jobs and waiting them to maybe complete or do whatever they want to do, right? So in this, like basically what I feel is like these are suited for those jobs which have like low execution time with them. If you want to run smaller jobs and you don't want a low startup time, because you don't want them to wait to first of all span a cluster, first of all go you submit your job and then you wait for it to span task manager, job manager, and so on, then you can go with your Flink session cluster. And the resources, when it comes to the resource, okay, let's compare it with the job cluster also. I think that would be quite easy comparison then, and more meaningful comparison. But in terms of like job cluster, what happens basically in job cluster, you do not have any dedicated cluster running somewhere, but it's on the fly cluster that spans up when you submit your Flink job. So here, basically, what happens here, basically the client first requests for resources from the cluster manager. Now, if you're running on Kubernetes, you have your Kubernetes cluster like resource manager, right, which we saw. So it client requests that cluster manager to start a job manager. It starts a task manager, and then it submits the job to that dispatcher running inside that process. So, and then of course, like then you what is happening here? The task managers are basically lazily getting allocated, and the resources are being allocated to those jobs. And once your job is finished, your job cluster is being torn down. So it's the end of your cluster lifecycle. But in comparison to your Flink session cluster, your job cluster remains there as it is, right? So that's like the major difference between two, and some advantage, and of course you'll get some pros and cons are there for both of these cluster. Like in case of your resource isolation, uh, what happens you are totally dependent upon those task managers and job managers, right? Because which are already been running on your cluster. So say for example, if any of your job that is running on any particular task manager, uh, or basically any particular task manager crashes, so all the jobs that are running on that task manager will crash, and then they have to be restarted, and then you have to manage their state again. uh, but it's not in the case of job manager in your job cluster, because you have your dedicated job running, so you take care of its fault tolerance with that. You don't have to worry about the fault tolerance for all the Flink jobs that you have submitted to your cluster, right? And then it's more suited for what we have seen while doing testing on them. We span our job cluster whenever we feel like we have large running jobs and they are totally isolated from other jobs. I don't want to share my resources to them. I want some dedicated resources being allocated to these jobs. I'll go and span up a job cluster. Okay. And finally, there is a third type of cluster which Flinks also give us. It's a kind of Flink application cluster. Frankly speaking, I haven't did much more. I haven't played around with this Flink application cluster, because in production environment, you either go with your job cluster or either you go with your session cluster. But in this, it's a kind of a mixture of what I feel it's a kind of a mixture of your job and the session cluster. It also basically executes your job from a single Flink application. But I think the only difference it do is that it doesn't run your main method on that cluster, rather than it runs on that client. So I feel when you are low of resources, or you have some resource constraint, you can go with this cluster. It do act like a job cluster, but with less managed resources. And there's a resource isolation also there, because you have to package everything into a single bundle jar, which you want to deploy to your cluster. So you have to take care of your resource manager, your dispatcher, and everything from your single Flink application. Right. So let's see now. Basically, so we have seen. So let me move on. So we have seen what exactly my Flink cluster looks like. How many different types of jobs I can deploy to my Flink cluster. And when it comes to deploying it on any managed framework, which is for our topic is Kubernetes. So there are various ways you can deploy there. You can use your custom, predefined Flink, basically Kubernetes controller to do that, right? You can write your own scripts, your own YAML files to deploy your jobs. Then you can use any third-party managed service, which might not be free, of course, for which you have to pay. And then there are finally some open source tools and utilities which you can use to do that. And Google Operator is one of them. So basically this Kubernetes, this Google Operator is used for Flink Operator, and it acts like a control panel to run your Flink jobs on your Kubernetes. So how does it act as a control panel? It basically uses two utilities. One is your CRD, which is known as custom resource definition, and second is your controller pod. So and there are various advantages it gives you. So think of it basically it is extending your available Kubernetes control panel. It gives your own controller, which is known as a controller operator from Google, and it gives you a custom resource definition, which you can think of like a template, a customized or a kind of a generic template which comprises of all of your settings, like all of your Flink deployment settings, which you're going to use while you're going to deploy your Flink cluster. So you don't have to worry about them. So it gives you that. then it gives you a high-level abstraction of how to deploy your Flink cluster, and it basically preserves your native Kubernetes experience. That is, like, you can still reuse your kubectl commands. You can still use that same monitoring tools or techniques that you have been using, uh, and easily you can deploy your jobs on that top of that. And it's not only like these advantages, like some other advantages, like it helps you to build custom Flink images. So many times, like, you have to decide like which Flink binary you want to use while you're developing your application, because like I've seen in my working environment and in this production world, sometimes, for example, if you're using JDBC connector with your Flink, it has to be of some lower version, because the higher version of it's not available. Then you have to Flink is right now, I think 1.11 is the Flink version, which is down there in the market, which is like the latest version. So you have to make it compatible, and then you have to decide which Flink like binaries that you have to combine and use. So it helps you to like create your custom Flink jobs, and basically it helps you to deploy those jobs into the cluster. It helps you to create your session cluster, which we talked about. It helps you to create your job cluster even. Not sure about the application cluster, but yeah, it helps you to even run your job remotely, and provides you like configurable namespace and so on. Like, there are multiple like advantages that you can even go and check it out. But yeah, here in like in Knoldus, we started with this, and it's like pretty good operator that is being used by us. And so this is like another diagram which I think we have already talked about. So you can see like there are two components that are being used. One is your CRD, which is your custom resource definition. So whenever a user submits a job to it, it talks with the CRD and it validates your properties or whatever your requirements are there, and then it pass it over to your controller. So this is your Google controller operator. It's not your Kubernetes operator. So this is your controller which decides like, oh, how do I need to spin this job? Where do I need to spin these jobs? It internally talks with the Kubernetes like resource manager to get the resources for your jobs, and it does the work. And as I told about, like, it gives you this kind of abstraction, because you don't have to worry about for all other like settings or like properties that you have to manage. It gives you a very like it's a YAML file. Like, it's give you a pretty good YAML file, which we will see in like in the demo, and to define your properties. And it's like pretty simple to do that. Plus, on top of that, what does it do? It persists those like kubectl commands, which like I was mentioning before. So you can deploy this operator, or you can deploy the jobs using your kubectl like command line tool, or you can use your like Helm charts. So generally, like in production environment, we use some standardized way to manage our like templates and to manage our resources. So Helm is like one of the way you can create standard templates. So you can use that tool also, and it will connect with your Google controller to deploy your jobs. Right. So let's move on. Yeah. Contribution. Okay. So basically, when you work on any like open source tool or any software, so throughout your journey, you'll see like you'll find many bugs in that, or maybe any possibility for improvement. So and then you tends to like contribute to that. And in Knoldus, like basically we love to do that. We enjoy doing that. So while we are like working on this Google Flink operator, so we found out like various improvement areas, and like these are two. So I don't know, like I don't have Ayush with me right now. So I have like a DevOps. So Ayush Singhal is basically a DevOps consultant here at Knoldus in India. So we work together in this in this project, and his two PRs successfully got merged into the Google operator. And even like you'll see more coming from us. We are still working on more. So let me give you a quick brief of these two, like what exactly we tried to do. So So on the top, you can see like there's it's written like add image, pull secrets, and node selectors. So if you remember, like we talked about, there are two components in Google Operator. One is your CRD and one is your operator. So what was happening previously, when you deploy your operator on your Kubernetes node, there is no way you can control on which node that operator would be deployed, right? So it's basically what we did. We introduced a placement constraint for the controller, because in production environment you don't want your like operator or any of your services to be deployed in any of your X node, which you don't have like control on it. Or basically, because you basically what you do, you allocate like certain amount of resources to a particular nodes, you tag those nodes, and then you want like some specific set of services should run on those tagged nodes. So that's what like this pull request like comprises of. And then the next one is basically add your resource in job template. So if you are like aware of deploying like job cluster or session cluster, so in that you basically have to give resources to your job manager and you have to give resources to your task manager. Those are like pretty specific and decent things to do that. But apart from that, you also have to specify resources to your job, to that jar file or that application jar that you're gonna run on top of those. Because like in your prod cluster, sometimes you have resource constraint, and even like it's not sometimes, you always have resource constraint on your node, and you don't want to exceed on that resource constraint. So you have to give like some resource like constraint to your job, which you are gonna run apart from your task manager and job manager. So this is apart from task manager and job manager. So don't get confused on that. So that's what like we did. It's not a compulsory thing. Like before that, also the Flink operator was working fine. But it's again like when it comes to your production environment, and if you have such constraints being enabled on your node, then you'll end up into like a black hole. So again, so I have provided you the links also. I think I'm going to share this slide afterwards, and you can hop on these links and to see more about the contribution. So I think that's all from my side in respective to in the theoretical part. I think we have enough done the theoretical part. So let's do some demo. So what I'll do, so in the demo, what I want to do, or what we'll do is that I want to show you that how basically you can create a job cluster, how easily you can create a session cluster, and then how you create your jar first of all of your application, and then how you deploy that using this Flink Google operator. And we're gonna do this on the Minikube. So let me. I think it would not be visible. So let me do one more thing. Let me stop this and just give me a second, guys, and let me share my entire screen. Maybe that would be easy for me because I have to switch between IntelliJ and then I have to switch between the terminal. So, okay. So I hope this is visible. So let's. Okay, hope like my screen is visible. And let me do one thing. Like I'll do one thing. Okay, great. Thank you. So let me start a Minikube cluster, and while it gets started, we'll discuss about it. Okay, so I didn't like I don't want to start it like from start, like because it takes too much memory. So let me go back to my application. Let me show to you like what exactly we are gonna try here. So this is my Flink application, Flink Kafka Kubernetes example, and this will be provided. I'll made it available for all you guys to try it out, which I'll show you afterwards how to do that. But like, so this is my basic job. Okay, so my job basically starts from here. I create an environment. So this is my execution environment, which I was talking about. Then either you can like have a batch execution environment. You can have a local execution environment if you want to run it locally on your IntelliJ, or you can have a stream execution environment if you want to build your stream jobs. So I have created this method. So it's a kind of a HOF function where it returns you either a local execution environment or a stream, basically a stream execution environment. And then you can set up like all of your other like Flink properties. For example, do you want to have any restart strategies? If something goes wrong in your cluster, what do you want your job to do? Do you want it to just like get it killed and notify you, or do you want it to retry and restart again, or maybe restart again? Then you can specify the checkpointing. Like where do you want to even like where do you want to save your checkpointing? You can specify it. So Flink gives you three options, I think, like the SGF, like the file systems, and then this is like rock state DB. So I have chosen like rock state DB with me. Then let us go back. Okay, so once I get my execution environment, I want a data stream. So what I have done, so I am fetching a data stream from a Kafka. So this is my create Kafka consumer. So what we're gonna do, we're gonna consume something from Kafka, and then we're gonna filter it, gonna parse it. It's like it can be any of your business logic. And finally, you're gonna dump that back to your Kafka producer. Okay, so this is my Flink application, and for that, what I have done, like I have added the examples for Minikube. Like if you want to try this example, you have like you can install Minikube on your Linux or Mac machine, whatever you are using. So you can leverage these scripts. So once you have your Minikube cluster up, what we're gonna do, I have a deployment doc ready with me. Yeah. So once our cluster is up, we will install Kafka on that. It won't take much time. Don't worry about it. Let's get back. So it's still starting up. Let me know like if I need to increase the font size, or is it like quite sufficient? Okay, I hope like it's quite sufficient. Okay, so
yeah, that's good.
Okay, great. Hope it starts. So nothing should go wrong. Okay, so let's go back. Like let's not waste our time. And so we don't want to discuss anything about Kafka. Like we have like generic Kafka like Helm charts being prepared. So I'm using Confluent Kafka here. You can one can use anything. There's a Rustmeister Kafka available, or you can have like another managed Kafka on Flink, or sorry, on Kubernetes. Then this is the job operator which I was talking about, and which we were talking about. So this is the job operator, and these are the and these. So because we are deploying our job operators from Helm command, so I have built like Helm charts out of it. So this is your custom CRD. That is your custom resource definition. So if you can see, like it comprises of all those settings which I was talking about. It's a kind of your one-on-go template which you can use to determine like which all properties do you want, and you can use these like available properties to spin up your Flink cluster. So yeah, so this is your custom resource definition from current version 0.3.0. And then once you have your definition, this is your operator, like which determines like what to do basically with all those set of information which it would be handling from the user, and it deals basically with spinning up your X cluster or X resources on your Kubernetes. So these these all are available from the Google operator itself. So you don't have to worry about that. What you have to worry, or basically what you don't have to worry, actually worry is the wrong word. What you have to configure is your values.yaml file, which basically determines like if there are any resource constraint that you want to have, or any security constraint that you have to have, or basically which operator image do you want to use? Do you want to use the like the latest available image, or you can even download the Google operator image, the code from GitHub, and you can customize your that image according to you. So that's what I have done. I have downloaded that Google Flink operator, and then I've customized the image, and I have pushed it onto my own repo. So it gives you that leverage opportunity also to do that. And the one that I was talking about, and that in this Flink operator, it was not having the resource constraint, basically constraint. So I think we added it in here, and it should be to work control. How do you do? Yeah, it should be the node selector, right? What do we? Yeah, node selector. So this is like the piece of code which was added. Like you can provide the node selector wherever you want to deploy your operator with. And the second thing was your resource manager, for your job cluster, that you'll see in your job cluster. So whenever you spin your Flink job cluster, so let's talk about that also before we deploy. So when it comes to like deploying a Flink job cluster, so this is like the same operator like Flink settings that we're gonna use. So I just like whatever the required settings I feel for my job, I just pulled them up from there. For example, like which image I want to use, environment variables, like configurations for my environment variables that I want to pass, and the job manager, what are the like settings for the job managers that I want to give. Similarly for my task manager and for my job, and finally for my job. And then like any other like Flink properties like that you want to have, like for example logging, you want to control your logging, or you want to basically add some other properties that may be specific to your cluster, or that may be specific to your job manager. You can even do that. So all these things will be overridden in your values.yaml files, or basically the values to them would be provided from your values.yaml file. So you can see all those properties that we have declared or have been using in our Flink cluster YAML. We have like given them a value. So you have your job manager with this resource constraint, or I don't want to have any node selector right now. Similarly, your task manager with one as the replica count. So basically, I want to spin a single task manager. I want to spin a single job manager, and then I want to spin my job afterwards. So this job is basically is being attached in your let's say I have created a Docker image out of it, and I have like pushed that Docker image. So this is the Docker image that I'm going to use to run my job, and in that Docker image, this is the jar file basically which I have to run, and this is your class name which will run, which contains the main method. And I can specify like this is the parallelism which I want my job to follow, and this is the resource constraint that I was talking about earlier, that you can even limit that how many resources in that container or in that Dockerized container your job will be using. So it's not like you can control it. It cannot use like all the resources for your task manager, which you don't want to do in the case of job cluster. But yeah, in the case of session cluster, you want to do that. Then these are the Flink properties like which you can like override and use. These should be, of course, these properties should be the generic properties that Flink supports. And then finally, your environment variable to your job. So let's go back and see if this is up or not. Okay, great. So let's not. I think we are not concerned about Kafka. So let's do one thing. Let's start with deploying the operator first. So this is my hint. So these are the like we already have gone through this Flink operator, and on the top, and I just want to deploy this operator, and let's see like what exactly will happen once this is done. Okay, You have qctl get pods for that, right? So you can see like there are basically two things that are getting deployed. One is your operator controller manager. This is your controller on top of your Flink, on top of your Kubernetes from Google, and this is just like a certificate that has been installed to basically do your authentication or internal authentication by this operator. So let it start, and then what we can do, we can see the logs basically. Okay, so it says container name must, yeah. So it tells you like there are two containers basically that are running inside this operator. Which one do you want to use? So I'll go with this Flink operator, but this is the one which I'm concerned about. Capital C or what? Yeah, so it hasn't yet started, so you'll not be able to see the logs. But yeah, so that's the whole thing that you have to do. And now you have a keeper like with you present for you on Kubernetes. Now you just don't have to worry about like creating those large scripts or managing your cluster. You just have to create simple YAML files with defining only your properties that you want to run for your cluster, and hand it over to this operator, and it will take care of everything. Let's see the pods. It's still creating it. It should work fast in Mac. I thought like Mac is much more faster than Linux systems. Okay, let's go back. And then what we're going to do next is that once my Flink operator is up, I'm going to deploy my Flink job cluster. And as you know, like the Flink job cluster is not a standalone cluster. It will first span the job manager, it will then span the task manager, and then it will submit your job to the available task manager. Uh, and once that job is done, yeah, like it will get destroyed, or even like you can destroy it. So it's a dedicated cluster for this specific job only. So let's see, hope it is up. Come on. Let's do one more thing. It's starting. It is like started container. It is starting that. Okay, done. So we have the operator up, and you can see like it has started the Flink operator on this. Now we so let's now start our job cluster. Okay. You can see there was no like dedicated cluster was running on your Kubernetes. As soon as you submit a command, the command would have been gone to the operator, and it should start the job manager first. Then once the job manager is up, it will span the task managers according to the requirement which we have given. So if you remember in the we are doing a Flink job manager, the job cluster. So we want only one task manager with us, which can have like 2 gigs of RAM in it. So it should do that. Let's wait for a few minutes and we would be good. Now, then what we're going to do, once our job manager is up, our task manager is up, then our job will get submitted. We'll see the job. Yeah. So if you remember, there were two modes we talked about in the early stages of the slide. That is your detached mode and your attached mode. So by default, right now, this Flink Google operator supports the detached mode in when you deploy your job using your job cluster. So you're gonna see like it would submit your job as in your detached mode, and you'll get the same kind of log like log which we saw previously. But yeah, we can hop onto the UI to see like what's the status of our job. Did actually whatever we have requested, did we got the same like configuration clusters or not? Okay, and similarly, like when it comes to your session cluster, so this is like your dedicated like session cluster. The template remains almost the same. Only thing which would be missing is your job, because you don't want to run any particular job on this cluster, but you just only have to take care of your job manager and task manager resources, and of course other Flink properties, and that's all. Like so, while doing this, it will span up a dedicated Flink cluster, which will remain there until unless you drop it out, and then one by one you can submit your jobs and like wait for the good result. Right. So that's like everything which we have talked about. We talked about the job cluster, we talked about the operator, we talked about the session cluster, which we will see once this is up. Oh,
In the meantime,
yeah, let's
is
just,
it okay for a question?
yeah, of course, I was going to say that only. So until and unless this whole demo thing works out, let's start interacting with each other.
So you spin up a job cluster.
Uh,
Where is the definition of the job in
no,
your YAML that you submit?
Okay, so I submit a job cluster. You mean to say the job cluster, right?
Yes.
Okay.
So you are creating already a job cluster. That means the cluster know which job it is going to execute, right?
Right, correct.
So then what is the job definition and what does this job do?
Okay. Oh, so as we saw, like this is the YAML file which comprises of this job cluster configuration. So here you can see like this is the job definition which you gives, and to provide the values for this, you specify those values from values.yaml, and this is your job configuration. So I have like bundled my job in a Docker image, and I pushed it on one of my repo. So this is my repo where my job resides. And then what my so it's like this it's self-intelligent. What it will do, it will pull out this job, this image. It will search for this jar file present at this path. Of course, like when I would be creating a Docker image, I have to take care that this is the place where my jar file should end up, and I'll show you that also how I did that, and then whatever like properties that you want to pass, and your job will run. And for your actual job, like this is my Docker file. Yeah, this is my Docker file. Yeah, so this is how I've created my jar file. Pretty basic. Like I did SVT assembly to create a jar first of all, and then after once my jar is created, I downloaded the Flink image, and inside that Flink image, I bundled my jar in opt/Flink location. It can be any location, of course, but like I bundled it, so that's why once this image is being used, so this is your custom Flink jar. So indirectly, we talked about like we can create your custom Flink images. So this is your custom Flink image which you are using. And yeah, that's all. And maybe to answer your question, what will this job do? So this is exactly this job which we talked about. Like it will consume from a Kafka, and it will produce back to the Kafka. So this is like the whole code which would be working in this job.
So it reads something from Kafka and it put the same thing back to Kafka, and that all it does?
Yeah, it's a pretty simple job. Like
no transformation in between?
No, it's depend upon you. Like the transformation is up to the business logic, right? Whatever the transformation you want to do, you can do that. So what I did, like I just fetched the events, I fetched the message on from those events, and then I'm just shipping them back to the producer. That's all.
Okay.
I don't want to put like a heavy business logic on right now here. So okay, so I have the task manager up. I think it got the resources, and my job manager is still struggling. At least there is no error. It's pulling the image and it's creating the container for it. So that's a warning. That's nothing issue. Like we don't have like I haven't done the readiness check, but yeah, in production environment you can do the initial readiness check about the state of your node where you want to run your job cluster. But it's not like super important here at this time. Okay, guys. Any other like questions? Any other thoughts which is coming to your mind?
So quick question, Piyush. I know that you had been working with Spark as well on some of the earlier projects. So how do you compare between the two, between using Flink and Spark? Where do you think one of them is better than the other?
Frankly speaking, like I believe both of them does the same thing. It generally depends upon the situation, like where do you want to use them. Because like in Spark also you can create a batch streaming batch jobs and streaming jobs, and similarly in Flink also you can create like batch jobs and streaming jobs. But yeah, the most best advantage you'll get with Spark is that if you really want to go with the batch processing, then Sparks give you much better way of handling it in terms of performance, in terms of handling your job, checkpointing, and everything all. In Flink, there is a little bit restrictions, or like kind of, I'll say a little bit like you have to do some tweaks to get your batch job done. But like Flink is super convenient and easy in streaming jobs, and Spark is super like easy for batch jobs. This is what like I have seen in my like development experience.
Okay. And from a windowing perspective, for both of them, it stays the same, is it?
Yeah, it's same. So windowing logic, aggregation logic, it almost like remains the same. It's
Got it.
same like you have sliding window there, you have sliding window here. The concept, like the terminologies, basically remains the same.
Got it. Got it.
And probably the Spark SQL is more flexible on the Spark side than Flink as well.
Yeah, of course. Like then you have Spark, then you have like 100 of libraries there with Spark, but that depends upon your use case if you really want to use them. It's like similarly with the Flink, you have like with Flink you have like streaming Flink APIs, you have streaming Flink sync, uh, uh, and like other APIs that can be used. You have data table APIs also, so you can somehow use your SQL kind of knowledge to like play with the Flink. But yes, there are more libraries down there at the Spark side. So yeah, so we are waiting for that to be done. Okay. So we have the job manager and the task manager up. So let's do one thing. I'll because like I have to show you the UI. So how do we do that? It goes forward, right? What I'm doing, like because I don't have any like ingress or been installed in my Minikube, I just want to make the UI visible on my local network. So I'm just forwarding this service to my local host on a particular port, that is 8081. And inside, so this is the like my local port. This would be my local port, and this is the port which is running inside this pod. So Kubernetes by default runs. The Flink job manager by default runs on 8081. So my 8081 is already in use. So let me just from my 8081 is already in use. Okay. So I have tried with 8082. Let's go back to there. Open 8082. Sorry guys for this like I think slowness. I have like limited resource with me right now. So that's why I'm using that. So yeah, here. So here you go. So what we were seeing down here is that we saw that we have one task manager we have one job manager. We haven't seen the job yet. We'll see that. So this is like one of your task manager is up with two slots. So that determines your parallelism work. Then you have so this is your task. This is your task manager with your CPU core, and this is like the Flink managed memory which I was talking about, which get distributed among the slots. And then this is your job manager, which is running with all like the default settings that I have provided. And there is no running job yet because I hope the job has not yet been submitted. Let's do one thing. Oh, this got. Let me open another terminal. I'm just like checking if my job is up or not. Okay, it has started. You see like as my job manager and task manager is up, now the operator has got a green go button like signal to deploy the job. So it has, what do you think like what it could be doing? What do you want to do? Let's see the logs. Oh, what a good timing. Okay, so it is like basically it fired a submitting command. So basically this is it uses that Flink binary which we have bundled. It uses this run command, and it gives the job manager path, because like we already have defined in our CRD where would be my job manager would be running. So this is the URL for my job manager, and like by default it runs on 8082. Then we pass some like custom settings like what would be my class name, what would be my job name, what would be my parallelism to my job. And by default, as I told you, it runs in detached mode. So it says like your job has been submitted with this job ID. Your job is being submitted in a detached mode, so you cannot see much like logs from here. So that's the last log which you'll see, and but you can of course go back to your UI, and here is your job. Overview. Yeah. So let's go inside. What is happening? Yeah, we don't want to care but this is like the gist of how do you deploy your custom job basically on a dedicated custom Flink job manager that has been dedicated to this job. And similarly, what you can do, you can just deploy a dedicated session cluster, and then you can submit jobs as per your need basis. There must be something happening. Yeah, so it gives you if you have worked with Flink, you would be aware of these all UIs. So it gives you pretty good exception. Okay, so I'm having something trouble with Kafka. Oh, so maybe I haven't given the right URL, but yeah, that's another issue to handle. It has nothing to do with this. Then you can use the UI as you would have been using, and I think that's all. If I close this, yeah. So similarly, if you want, we can spin up a dedicated session cluster, and then we can deploy jobs there. But yeah, that's the gist of this. How do you want to control so the main thing that you have to take care is that, do you want to go with a job manager? Do you want to go with your session manager or session cluster? Then how many task slots, how many basically resources do you want to allocate? And then what all properties that you want to have in your template? And if you are using Helm charts, so that becomes it gives you a very easy manageable way to define your properties and your values, and that's how you do in the production environment. So coming back to our slides, yes, really gone stuck. Okay, so I hope this is visible. Yeah, so guys, I was telling you You can even try the example that we just saw it. So it's available on Knoldus Tech Hub. So like you can hop on to techhub.knoldus.com, and then so basically this is the environment where we have curated list of templates produced by Knoldus to help you out for your learning and for your development. Basically, these are some accelerators which solves your business use case. So I think we have more than 20 plus technologies available with us right now, and like more than like 500 templates down there. So you can just hop on to this techhub.knoldus.com, and under the Flink category, you can find my template down there. Okay, and yeah, these are the references where I took all this reading material. And thank you. Thanks, guys. Thanks for joining and attending this meetup. I hope like you learned something and you liked the presentation. And of course, hope to see you soon again. And yeah, again, like any questions and anything that we want to discuss.
Bravo, thank you very much, Piyush. That went a little bit fast, but all right, that was very valuable. Thank you very much.
Sure, thanks, Tree. Any questions, like guys, anyone from? You can like again reach us out. Like you can reach me out, or we have like Vikas. He's the owner from Knoldus, so you can reach him out like Vikas@knoldus.com or Piyush from @Knoldus. I think I would be sharing this slide, right, Sean? We would be sharing these slides on the Scala Toronto Slack group. If you are not like on this group, then I request you to please join this, and we will be in touch like anytime.
Thank you, Piyush. This was great.
Thanks, Piyush. Yeah, you can put a link to the slides on the Slack group. If you give me the link, I can also tweet it out with the recording once that's ready.
Yeah, sure. I'll send you the link, Sean, and once that recording is ready, like whenever you are done, we can post it on the Slack, right?
Yep.
Okay. Great. Thanks, guys. So thanks for joining. It's almost time. Then have a good night, and then see you soon again.
Thanks, Piyush. Thanks, everybody.
Bye-bye.
Thank
you.